Okay, we have several of these logarithmic expressions to evaluate. The first one we have is log base 2 of 512. So let's take a look at our process here. I like to say that it equals something, and z is as good a letter as any. So we circle the base, put a box around the exponent. 2 to the z equals 512. And we need to figure out what that is. So let's see, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7th is 128, 2 to the 8th is 256, and 2 to the 9th is 512. So I will then say 2 to the z equals 512, which is 2 to the 9th, which tells me that z equals 9. Therefore, log base 2 of 512 equals 9. So that's the process that I like to do this. Set up the exponential equation, look at your exponential numbers, and then match. Okay, what do we have next? Log base 8 of 8. That's certainly a little easier. Log base 8 of 8. Equals z. So same process, circle, box. 8 to the z equals 8 is our exponential equation. If I have 8 to the z equals 8, well, what is 8? 8 to the z equals 8. Well, 8, of course, is 8 to the first power. So 8 to the z equals 8 to the first, which tells me then that z equals 1. So log base 8 of 8 equals 1. And you'll soon recognize that pattern, that log base something of the same something is going to typically equal 1. All right, what's next? We have log base 3 of 1 over 27. So I'm going to again give it an exponent, call it z. Circle the base. 3 to the z equals 1/27. So we need to figure out what 1/27 is as an exponent. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. So 1 over 3 to the third is 1/27. But what is 1 over 3 to the third? That, of course, is 3 to the negative third is 1/27. So we get 3 to the z is the same as 3 to the negative third. So z equals negative third, and we finish this off and say log base 3 of 1/27 equals negative 3. How do you check it? 3 to the negative third equals 1/27. Okay, what's next? Log base 4 of 2. It's a little more challenging. Log base 4 of 2. Log base 4 of 2 is z, so 4 to the z, circle the base, box around the exponent. 4 to the z equals 2. You'll notice 4 to the first is 4, 4 to the second is 16, 4 to the third is 64. You're not going to come up with 2. 4 to the negative 1 is a quarter. 4 to the negative 2 is a 16th. Again, you're not going to come up with 2. But what you do know is 2 squared is 4. So what I can do is I can replace 4 with 2 squared. 2 squared to the z is 2. When we raise a power to a power, we multiply exponents. I hope you know why, or can think of an example to convince yourself of that. So 2 to the 2 to the z is 2 to the 2 times z. So 2 to the 2z equals 2, but 2 equals 2 to the first. Now I can say 2 to the 2z equals 2 to the first. 2z equals 1. Divide 2, divide by 2z equals 1/2. So our conclusion then is log base 4 of 2 equals 1/2. Again, how do you check it? 4 to the 1/2 power equals 2. Is that true? Again, circle the base, box. 4 to the 1/2 equals 2. 4 to the 1/2 means square root of 4 equals 2. Check. So yes, indeed, log base 4 of 2 equals 1/2. Next, we have log base 7 of the cube root of 49. Log base 7 of the cube root of 49. So our usual strategy, like I say, let it equal to z. Circle the base. Box the exponent. 7 to the z equals the cube root of 49. What is 49? Right, 7 to the first is 7. 7 to the second is 49. So I get 7 to the z is the cube root of 7 to the second. But I hope you recognize that form. But the cube root of 7 to the second is the same as 7 to the 2/3. So we get 7 to the z and 7 to the 2/3, and z equals 2/3. So we conclude with our question, which was log 7 of the cube root of 49 equals 2/3. Is our final answer to that. Next, we have ln of e cubed square root of e. Remember, ln means log base e. Ln e cubed square root of e is where we're at. So we're going to call that equal to z. Ln is really log base e of e cubed square root of e equals z. Ln means log base e. Circle the base. E to the z equals e cubed square root of e. E to the z equals e cubed square root of e. Well, what do we need to remember? Square root of e is the same as e to the 1/2. So e cubed square root e is e cubed times e to the 1/2. So e cubed square root of e is e to the 3 plus 1/2. That is 7/2. So e cubed square root of e is e to the 7/2 by the time all was said and done. So we get e to the z equals e to the 7/2. So that would tell me then that z equals 7/2, or the natural log of e cubed root e equals 7/2. So this is probably a good one to check on the graphing calculator. So let's see what we get there. Natural log, which is ln, again, remember that means log base e of e cubed. That second natural log is e to the x, e cubed times the square root of e, square root of e, which I think I just have to call it e to the first, square root of e to the first. And we hope we get 7/2. Let's see if we do. 3.5, change that to a fraction just to check. And indeed, that is correct. All right, let's see what our next question is. We have log of 100. What will that be? LOG 100. Remember, LOG really means log base 10. So currently I have LOG of 100 equals Z. I'm going to write down what that means. That means log base 10 of 100 equals Z. Then we circle the base, box the exponent, 10 to the Z equals 100. But what is 100? Well, 10 to the first is 10. 10 to the second is 10 times 10, which is 100. So 10 to the second equals 100. So I have 10 to the Z equals 10 to the second. So Z equals 2. And LOG of 100 equals 2. And that's easy to check on the calculator. LOG means log base 10. LOG of 100 should equal 2. And it does. All right. Our next question is log base 4 of negative 16. Log base 4 of negative 16. Let's talk about this one. Log base 4 of negative 16. Well, fine, say that equals Z. That means 4 to the Z equals negative 16. Well, let's look at some numbers. 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. I'm not seeing negative 16. 4 to the negative 1 is 1/4. 4 to the negative 2 is 1/16. 4 to the negative 3 is 1/64. 4 to the 1/2 is 2. Can 4 to something ever be negative 16? Let's take a look at a graph if I can. Let me see if I can get Desmos ready. Should be able to get Desmos ready. I want to look at the graph of 4 to the Z and see, does it ever equal negative 16? That's our goal here. So what do we have? I can't graph 4 to the Z. I'm going to graph 4 to the X instead. Never a negative number. That is not part of the range. So there is no solution. And that reminds us of something. You cannot take a log of a negative number. So log base 4 of X, the domain of that, right? Log base 4 of X, domain only allows you to have values where X is bigger than 0. You cannot take log base 4 of negative 16. There is no solution, at least no real solution, we'll say. No real solution to log base 4 of negative 16. And I believe I have one last question, which will be similar to that, which is log base 2 of 0. What is log base 2 of 0? The circle the base, 2 to the Z equals 0. 2 to the Z equals 0 again. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. I'm not seeing 0. 2 to the negative 1 is a half. 2 to the negative 2 is a quarter. 2 to the negative 3 is an 8. I'm not seeing 0. Am I ever going to get 0? No. I mean, you may get close, but you're never actually going to get to 0. So again, no real solution. So again, it reminds us you can only take logs of positive numbers. You cannot take a log of 0. So log base 2 of 0 is not going to have a solution.